For more physics-related videos, please subscribe. In this video, I'm going to cover the top 10 physics books that every young physicist needs. This is not an objective list, it is my personal opinion, based on what books have been most useful throughout my physics career, as well as books I noticed were often used by many other people in the field of physics. Of course, if you really want to be a successful physicist, you're going to need more than 10 books. So let's start off with number 10, the Feynman Lectures on Physics. This is not actually one book, it's a set of 3 books that basically covers every single subfield of physics except general relativity, and maybe a few others. There's no nuclear physics, for example, but ultimately nuclear physics is just quantum, and the entire third book is devoted to quantum. But it essentially encompasses the entire field of physics, especially phenomena relevant to the human experience. The main reason why these books are so good is that Richard Feynman does an excellent job of presenting the material in an intuitive and easily visualized manner, even for very difficult concepts that generally are highly non-intuitive and difficult to grasp. It also contains examples of a lot of interesting problems and experiments. At number 9, we have Stephen Hawking's The Universe in a Nutshell. This is more of a pop physics book. You don't need to be a physicist to read this, but Stephen Hawking is a good writer and he's kind of a funny guy. And in this book, as the title suggests, he gives an excellent overview of our current understanding of the state of the universe. Current being back when this book was written, so a few things may have changed since then. But this is a very entertaining read, and it's actually a sequel to his first book, A Brief History of Time, which is also very good, but I personally think this one is a little better. At number 8, we have Classical Mechanics by John Taylor. In my opinion, this is the best undergraduate book in classical mechanics. Much like Richard Feynman, John Taylor has a knack for presenting things in a very intuitive and easily visualized manner. Even though this is an undergraduate book, I find myself going back to it on a regular basis just to see how he presents topics so that I may incorporate those methods in my own presentations. Moving on to number 7, we have Gravitation by Meissner, Thorne, and Wheeler. This is the book on gravitation and general relativity. If you're at all going to be studying or working on anything related to gravity or general relativity, this book is a must-have. If you're finding this video useful so far, please be sure to like and subscribe, and maybe share it with a few friends. Moving on to number 6, we have An Introduction to Error Analysis, again by John Taylor. Now, this is not a particularly interesting book, but if you're going to be a good physicist and a good scientist in general, you better know your error analysis. And in my experience, outside of math-heavy fields, most scientists could use a good refresher course in error analysis, as in general, it's not an easy topic, but a highly important one. And just as in his book on classical mechanics, John Taylor does an excellent job of presenting things in an easily understandable and intuitive manner, which when it comes to error analysis is saying a lot, because error analysis is not an easy topic. We now come to number 5, Introduction to Quantum Mechanics by David Griffiths. This is probably the most commonly used undergraduate quantum mechanics book, and there's a good reason for that. Quantum mechanics is highly non-intuitive, especially when it's first presented you in undergrad, but the way things are presented in this book, despite that you do have to scratch your head a little bit because it is quantum mechanics, really at no point do you feel lost or overwhelmed by the material. Everything builds clearly and methodically on previous concepts. Moving on to number 4, we have Quirky Quantum Concepts by Eric Michelson. This is not a very known book, but I highly recommend it. I've had the good fortune to attend a few lectures by Eric Michelson, and they are excellent. If you ever get a chance to see his lectures, I highly recommend them. He's an excellent speaker, he's funny, and he likes to talk about interesting and off-the-wall concepts that even most experts in quantum mechanics aren't aware of or have never really encountered. And this book is no exception. In fact, just as the title suggests, it contains all sorts of odd and off-the-wall effects that you generally won't encounter in most physics courses and textbooks. Moving on to number 3, Relativity, the Special and General Theory by Albert Einstein himself. Now, how could you not buy this book? Relativity straight from the guy who came up with it. The great thing about this book is that you don't need to know any physics at all to read it. There's almost no math in this book. It's entirely conceptual and anyone can read it. In fact, I read it before I ever took a single physics course. The little amount of math in this book can easily be followed by a high school student. In this book, you get to enter the mind of Einstein, where he paints you this picture of clocks moving at different rates according to different observers and curved space-time and lengths being dependent on your point of view, and he does all that without requiring you to have any background in physics. Plus, this book is only about 200 pages long. It's a pretty short read. At number 2, we have Surely You're Joking, Mr. Feynman by Richard Feynman. This is not really a physics book. It's more like a collection of funny stories and anecdotes throughout Richard Feynman's life as a physicist. So it takes place in the world of physics, but it's not a physics book per se. Nevertheless, this book is highly entertaining and hilarious. I highly recommend you read this, whether or not you're interested in physics. Before we get to our number 1 book, here are a few honorable mentions. Introduction to Electrodynamics by David Griffiths. This is an undergraduate textbook for electricity and magnetism, and it's written in the same style as his book on quantum mechanics. And just like that book, it's no accident that so many physics professors teach their introductory courses on electrodynamics out of this book. Next, we have an Introduction to Thermal Physics by Daniel Schroeder. Now, there are actually quite a few good books on thermodynamics, and I didn't include any in this list, so I wanted to include one here, because thermodynamics and statistical mechanics, in my opinion, is the hardest part of all physics. And this book is actually very intuitive. Finally, we have Quantum Mechanics by Landau and Lifshitz. This book is generally used for graduate level quantum mechanics, and basically contains everything you need to know about non-relativistic quantum mechanics. And I find myself going back to it on a regular basis. So, finally, at number 1, we have Classical Electrodynamics by John Jackson. This is by far, in my experience, the most widely and commonly used book in all of physics. This is a graduate level book, and problems out of this book are notoriously difficult. But if you're going to master electricity and magnetism, there's really no two ways about it. You have to go through this book. This book is so widely used that in my experience, it is extremely rare to find a graduate level electricity and magnetism course that is not taught out of this book. I don't think I know a single physicist that does not own this book. That concludes my list of top 10 physics books that every young physicist needs. If you found this video helpful, please be sure to like and subscribe, and if you'd like to see more physics-related videos, hit the bell to be notified for the release of future videos. Thanks for watching, and I'll see you in the next one.